All right, thank you for joining us on today's walkthrough video of our fifth grade acids and bases activity. My name is Dylan Elizabeth from In4All, and today I'm joined by
New system from Bernier. So I taught chemistry for a long time, and so this is a really fun activity that means a lot, especially in this day and age with the environmental effects of acids. So it's got a great amount of applications for students. So let's go ahead and walk through it a little bit and see if we can make it a little bit simpler for you to set up and collect data and so forth. So, all right, Dylan, let's take a look what we got. First thing, as Dylan pointed out a minute ago, download this presentation and personalize it. Put your names in and your pictures and all that kind of stuff, And then there's just a little, after you've done that, of course, you can copy that page if there's more of you. A little icebreaker here, right? What's your favorite character, in a video game or a comic book or a, TV or a movie? Just something to, get the kids involved. Here is, pretty obvious, but later we're in the second activity, you're going to be talking about cleaning water and testing water. And so there are places in the world where the water on the right, and actually even in the United States, not so long ago, particularly in Mississippi, where the water was not drinkable. So take a look at this, what's going on here, the tap water in Michigan. And like I said, just because of the rains that they had in the last few months, even in Mississippi, they had some real issues with tap water. So it's not necessarily a world thing. And so here's, if pipes are corroding and you're getting some oxidized material inside the pipe that can then get carried through the water, this is a challenge for some communities, especially older communities. Some of you may remember in Portland, just in the last half decade, there's some schools had some issues with drinking water because of lead pipes. So this is not, something that is just abstract. So what we're going to do first is we're going to learn about acids and bases, because this will be a way for us to analyze some of the water and see how acidic or basic it is, and what is considered good water that is drinkable and safe and that sort of thing. So it gives the students a chance to talk about that. Now, first thing to do is just ask them, have they ever heard these words before? Fifth grade, I'll be surprised if too many kids have never heard the words, but what sorts of things are acids, or what sorts of things are bases? One of the things that confuses some folks is that they think of acids and bases as chemicals, which they are, but some of these chemicals we eat, and that can sometimes cause a little consternation when you're consuming acids and you're consuming bases. But of course, there's many examples of acids and bases that you would not want to eat. So this is a great opportunity to check their knowledge a little bit about what acids and bases are. So how do we determine how strong an acid or a base is? Well, one way to do it is by using this pH scale. It's a little counterintuitive. The lower numbers are acidic, the higher numbers are basic. Neutral would be considered in the middle. One thing to be aware of is there is hydrochloric acid in your stomach, and that hydrochloric in your stomach has a pH of around 0. And so this is why when you have an ulcer, or if you have any kind of something that comes up in your throat, it tastes so sour. But it's part of the digestive process, and your stomach has a lining that protects you from that hydrochloric acid.
That's very interesting.
Yeah. So what about water? What's the pH of drinking water? Slightly acidic drinking water is not that unusual. You can buy water now that's alkaline water. There's no real proof that drinking alkaline water is actually more healthy for you. But water in the middle, pH 7 water would be considered exactly neutral. That's very difficult to actually keep water at pH 7 just because of the carbon dioxide in the air. But this is what would be considered good drinking water, pH between, say, 6.5 and 8.5. So let's think about this for a second. What's a hypothesis? Sometimes people will call this an educated guess. What it means is that you've done an experiment, or maybe you've observed an experiment, and now you're asking questions about another experiment. You're saying, well, if we do this, what will happen? What will the result be? And typically, you want to try to base that on some kind of an observation. So making a hypothesis based on no observations at all is actually not a hypothesis. It's a guess. So you need to have some background. So students will get this paper, and the pH scale, beautifully printed out, is going to be available to them. So they can look at that and use that to fill in the blanks in their hypothesis. So if we add an acid to water, how will that affect the pH? And conversely, if we add a base to water, how will that affect the pH? And then probably the most challenging question, it'll be, don't give them the answers, will be, what if you mix an acid and a base? What will the pH be if we put these two together? And all of these things are going to be done in this activity. So it's not, with my students, the concern was, what if we get our hypothesis wrong? And my answer to my students was, the only time you lose points is if you don't make a hypothesis. If you get it wrong, then you analyze why that happened. But you need to make a hypothesis. You need to put down some thoughts as to what you think is going to happen. All right, let's experiment. I'm not too fanatical about those goggles not being on the eyes, but looking through a microscope is very difficult with goggles. So I understand that. Okay, let's go ahead. So in your kit, you're going to be handing the students a bag that has goggles and test tubes in it, and some pH test paper here. So every student will get one of these. So the goggles are theirs. Every student will get 2 test tubes. Okay, so those, in most cases, they can just lay them on the counter here. I'm a little bit lazy, so I'm going to put them in a cup so it's easier to grab them. And then they should have a container that has some swabs and some pH test paper here. So that's what's going to be in the kit. Once it's open, once again, write your name. Well, have the students write their name, because we're going to need these goggles again. Okay.
Yep. And the one thing we didn't mention that is here for you, the volunteers, is you'll also have paper towels and washi bottles to fill the test tubes. Some safety reminders is that your safety glasses must be worn at all times during this activity, and do not drink any of the water from today's experiment. Probably don't drink water from any experiment ever.
Chemistry lab rule is you always wear your goggles, and you don't eat anything in the laboratory ever.
And make sure you do take time to have students write their name on their kit, because they will need to return these.
So let's get the testing ready. You're going to take the 3 pieces of pH test paper out of the baggie here, which I'm struggling with. Let me get the other one out.
It is a tiny baggie.
Okay, and you're going to do 3 tests. So not a bad idea to label, which one of these is which. And so let me do that very quickly here. And so that's the setup for the paper towel. Let me turn this a little bit so you all can see it better. Okay. And then the other thing to do is we need to fill the test tube. So you'll have a couple of wash bottles. Your kit will come with 2 of these wash bottles. You will need to put water in them when you get into the classroom. And what you need to do is fill the test tubes not quite to the middle, because eventually you're going to mix these. And so don't overfill them. Somewhere a little bit less than half. So you're going to put about, maybe a third. So leave a little space. Ideally, put the cap back on, particularly if you don't have a place like a cup to put it in. I'm guessing the students are going to lay it on the counter. You do have extra paper towels. You might hand out a spare so they can lay it on a paper towel. But point being that, you want to make sure the cap is on it, or some way to support the test tubes so that they won't spill. Okay. All right. Let me get this wash bottle out of the way so you can see what I did. Okay. All right. What's next, Ellen?
Looks like we get to test Test tube A.
So one thing to make sure that the students do, if you look in the test tube, you'll see that some of the material dissolves very quickly, some of the material does not. What you want to do is take the test tube with the cap on it and just tip it back and forth. Okay, and that will ensure that all of the solid dissolves in the water. You should end up with a solution that is basically colorless. And so then what you're going to do is you're going to take a swab, and I recommend that you use a different swab for each test. So what you want to do is take a swab and touch the liquid. It does not need to be drippy. Just, get a little bit of liquid on the end of the swab. And then just touch it to the papers. And so what the students then need to do is they need to take their pH scale on their data sheet, and they need to compare the color and decide on what pH that is. Every student should be doing this. So it's kind of fun to do. And then they just need to record that data, okay, on the data sheet in the appropriate spot. It's the same for the base. So this is the base, same process. Touch that onto the paper.
Ooh.
Notice that, I got a ooh out of Dylan. And so, note that, look at your pH scale, and then record that value in the box for test tube B. All right. Mixture. Okay, now. So what you're going to do is you're going to pour one test tube into the other. It doesn't matter which. So I'm going to take test tube A and I'm going to pour it into test tube B. Okay. Put the cap on. You may notice some bubbling. Okay. So when the acid reacts with the carbonate, the sodium carbonate, which is the baking soda, it produces carbon dioxide gas. And so depending on how well the stopper fits, this stopper, I think it's leaking. I can feel liquid.
I can see it.
So yeah, this one, sometimes though, when you do this, the top will pop off. This is a good time to talk about why are we wearing goggles? Okay. Not just to protect our eyes from the stopper, but also to protect from any liquid that might come out with it. All right. We're taking another clean swab, and we're going to test the mixture.
Oh.
Now that's interesting. The acid was reddish in color, the base was bluish purple in color, and you'll notice that the mixture is somewhere in between. This will be a challenge maybe for some kids to try to decide, did it change color at all?
Right.
So then the thing to do is to look on there and decide what happened.
How close.
Okay. But that's coming up. What you want to do then is for the combination is to record what you saw. Okay. All right, where are we at? So questions to ask the students, what did we learn about acids and bases? See what response, things new that they didn't know already. What would happen to water in pipes if an acid or a base was in the pipe?
Right.
Would that have any effect? One thing you might want to bring up is, does it matter if the pipe is made of plastic or if the pipe is made of metal? Because a lot of pipes in houses now are made of plastic. What was interesting or surprising? I want to hope that the bubbling gets a response. That's kind of can be kind of a fun thing. Anything that we didn't talk about that maybe you have a thought about that's related to acids and bases? Is there some other test or experiment that you can think of that we might be able to do?
So we have a QR code and a link. You will send these to the teachers ahead of time, but ideally we can get some awesome student feedback on what they thought, maybe what they would want us to do differently. Yeah, things like that.
So next time we meet, the plan is to take some water and try to clean it. And so one of the tests we will do, of course, is to test the acidity or basicity, the pH of the water before and after we clean it, to see if we can actually improve the pH of the water. So that's the plan for the next activity. Finally, before we finish, want to remind you, student's name on the baggie. Their goggles, every student gets a pair of goggles, goes in the baggie. As far as the test tubes go, dump them out. Okay, put the caps back on. Might need to have a cup or something handy so you can walk around the room, and then those go back in there. And that should be it, because all of this material is used, so this is just waste at this point. But the goggles and the test tubes need to go back in the baggie, and then these need to be retained for activity 2. So make sure that this gets put in the baggie so that you will have this big one, so that you will have this available for activity 2.
Activity 2 is in the big green bin that you will have received. And so your job is to make sure you collect all these at the end of the acids and bases activity and make sure to put this in your bin before you bring it for activity 2.
All right.
Yeah.
I think we did it. Okay, look forward to hearing from you all. I hope this activity works well for you. And we'll see you next time.
Thank you.